So let's have one more type, something different than the previous type which we have studied in transient analysis. Again, two conditions you need to check it before starting transient analysis sum. Either the condition can be initial condition, either the condition can be in steady state condition. So in this case, it is defined your condition is steady state. When your condition is steady state, my dear friends, that means your capacitor is fully charged, so it cannot accept more current, so it will be open circuit. Your inductor will allow the current to flow, that means it will be a short circuit. So let's start for the following sum. We need to find all these values in the above case. The arrow defines it will move down only at t equal to 0 plus, right? So let's start with the initial condition for the same. When I have t equal to 0 minus condition for the previous sum. So let's draw the network for the previous sum for the same. 0 minus, that means switch will be open. So your circuit will be 100 volts, 10 ohms, 20 ohms. What about the inductor? Mention it was steady state, that means inductor will allow the current to flow, that means it will be a short circuit. Further, when you move, you have a resistance and you have a capacitor. Since it was steady state, that means it is defined your capacitor will be your open circuit. So your capacitor, in this case, it will be a open circuit. Now let's find the following current and the voltages across the capacitor. I1. So now let's find the current I1. So you can easily apply mesh over here. So at the resistance, right, applying KVL in mesh 1 we get. So you got plus 30 I1 of 0 minus equal to your 100 volt. So your I1 would be straight away your 100 divided by 30. So use your calculator and write the value which you get. The value which you get in this case is 3.33 amperes. So when I talk about I2, my dear friends, since the circuit is open, so your I2 value will be 0 amps. So after getting I1, that's not it. You had an inductor, you had a capacitor. Because in steady state, my dear friends, when I go further in case 2, when I talk about t equal to 0 plus condition, so instead of inductor, my dear friends, I need to draw a current source. So in this, the value will be nothing but my I1. So my current source value will be 3.33. When I talk about capacitor, the capacitor was kept open because it was fully charged. So now I need to find the value for this capacitor, how much it is charged. A basic law, you know it? That voltage in parallel. So if I find the voltage for this, there is nothing but it will be the voltage for the capacitor as well. Now let's find the voltage across this branch, right? So if I need to find the voltage across this branch, the formula will be total voltage, that will be 100 into where I need to calculate 20 upon the addition of both the resistance. So let's find the voltages of the capacitor. So it will be voltage across 20 ohms, right? So I need to find voltage across 20 ohms, that will be equal to my dear friend. It will be total voltage into where I need to find the voltage 20 upon addition of both the resistance. So voltage across 20 ohms, it will be given as 100 into 20 divide bracket 20 plus 10. So the value which you get is 66.66. The value which you get is 66.66 volts. So this is nothing but the voltage across capacitor, which will be equal to voltage across 20 ohm, which will be equal to 66.66 volts. So now you can go for your case 2. That is nothing but your t equal to 0 plus condition. Now let's get for t equal to 0 plus condition. When I say about t equals 0 plus condition, now your switch will be closed. When I say your switch will be closed, your circuit for this case will look like for inductor, we will drawing a current source. 20 ohms. For capacitor, you will be drawing a voltage plus minus, which you have already calculated 66.6 volt, and the current value which you got from I1 was 3.33 amperes. Now you have two properties, my dear friend. For solving this network, you need to get two properties. The property is known as redundant property. The property is known as redundant property. It states whenever you have a short in parallel with a resistance, your circuit behaves in this manner. That means your resistance is removed straight away. Second property of redundant property. When you have a resistance and you have a current source, either in up direction or in down direction, so it becomes with only a current source. That means the resistance is short circuited and the resistance is removed over there, or you can say open circuit. So this two properties you just need to keep that in mind. When you have a short in parallel with the resistance, your resistance is removed. So when you have a current source, increase the resistance, your resistance is short circuit, right? So let's apply these two properties, redundant property in the above network. So the above network will be in this form. 10 volt. A short and resistance, so resistance is removed. So we are having only a short. 20 ohms, then you have a current source, 3.33 amperes. You have a resistance. This resistance will be shorted. A voltage source, 66.66 volts. So this resistance will be a short circuit because of redundant property. So now let's find the circuit currents. This will be your I1. This will be your I2. I can apply mesh over here because of this current here. I can apply mesh also over here because of the current source. So this is known as a super mesh condition. So apply a super mesh for this case. You don't have any resistance for I1, but you have a resistance for I2. So it will be plus 20 I2 equal to voltage current enters is positive, it will be negative. And the total voltage for the circuit is your 100 volts. So negative, it will be positive. So from there you will get the value for I2. Simplify by using our calculator, my dear friends. You will be getting minus 66.66 plus 100, the value which you get, divide by 20, the value you get is 1.66. That's the value for your I2 is 1.66 amperes. Now the second equation which you get is from this current source. Which current follows this current source, I1 or I2? You will say I1 follows this current source. So whichever follows this current source will be positive, which doesn't will be negative, equal to the current source value. You already got the value for I2, put the value over here, you get the value for I1, it will be 3.33 plus 1.66. The value of I1 which you get calculated, so you get 3.33 plus 1.66, the value which you get is 4.9, that is approximately equal to 5 amperes. So you got the value for I2, you got the value for I1 which you got from t equal to 0 plus condition. So you can write this condition as I1 0 plus equal to and I2 0 plus equal to. I1 the value which you got is 4.99 amperes and I2 with the value which you got is 1.66 amperes. That's not it. Again further you need to write the voltage across capacitor, that is nothing but 66.66 again in this case. So further I need to find di1 upon dt. So let's go for it, and di2 upon dt as well. For that, whenever I need to find di and in differential form, I need to solve t greater than 0 condition. Without this condition, I won't be getting a differential current, right? So let's go for this condition. When I go for this condition, please make sure you never open your resistor or inductor or a capacitor. So please make it sure about that. Okay, so let's do it for the steady state condition for this circuit. For the steady state condition, your inductor is in parallel with the current source and your capacitor is in series with a voltage source. So let's draw the circuit, my dear friends. So your circuit will look in this manner. You have 100 volts, you have a resistance, you have an inductor, the value is 1 Henry, steady state, so you have a current source which is parallel to it, the value of current source is 3.33 amps, you have a resistance, the value is 20 ohms, you have a capacitor, the value is 1 micro is 10 to the minus 6. So when you have a capacitor of steady state, so you need to draw a voltage source in series with it. So this will be your circuit, and the voltage which you got is 6.66 volt. So now I need to find the current, that is I1 and I2. I need to find di1 upon dt, I need to find di2 upon dt. Now let's go for it. Let's apply the KVL in this case. Since I cannot apply KVL because of this current source, so let's apply KVL in this case in mesh 1. So I hope this network you have drawn in your book. So let's apply it. So your KVL in this mesh would be, you have only one resistance, right, my dear friends? So your circuit will be applying KVL in mesh 1 you get. So you have only one resistance, that is nothing but 20 I1 of 0 plus. So you have inductor as well. So you have the voltage across inductor, the formula is L di by dt. The value for L is nothing but 1. This will be 0 plus upon dt. So now you need to observe, is there any other current flowing in inductor or resistance? So you will say yes. In resistance there is a current known as I2. So it will be minus 20 I2 0 plus equal to any voltage source in mesh 1. You will say yes, you have one voltage source and your current enters into negative, so it will be 100. So that will be your equation number A. Now in this case you have I1, you have I2, and you will directly get the value of d1 upon dt. So let's put the value of I1 and I2. So it will be di1 upon 0 plus upon dt equal to, you have 100 on this side, shift that side, so you will get minus 20 into I1. The value for I1 which you got is 4.99. Shift that side, so you will get 20. The value of I2 is which you got is 1.66. Simplify, so di1 upon dt is equal to, would be equal to, this will be equal to 100 minus bracket 20 into 4.99 bracket close plus bracket 20 into 1.66 bracket close. So the value which you get is 33.4. So that is your value for this differential current source and the per unit second. So this was the differential part for I1. Now let's do it for I2. For I2, my dear friends, I cannot apply the KVL in this because of this current source. So I need to apply the KVL for outer path for I2. So let's apply the KVL for outer path, right? For outer path, I have this resistance, capacitor and this voltages. So let's apply for it, very simple. So I'll be writing, applying KVL in the outer path, KVL and outer path we get. So you have one resistance, so your value will be 20 I2 of 0 plus. Capacitor voltage is nothing but 1 upon C. The C is 1 into 10 raised to minus 6 integration I2 of 0 plus to dt plus. You have a voltages, you again have voltages, so it will be equal to, you have two voltages, so you enter into positive, you write negative, you enter into negative, you write positive. So now let's differentiate this kind. So if you differentiate this equation, because I need to find di2 upon dt, right? So since I don't have that, so I need to differentiate this equation number b. So let's differentiate equation number b. So I get 20 di2 upon dt plus 1 into 10 raised to minus 6. Your differentiation and integration will cancel each other, so it will be only I2 0 plus equal to, since everything is constant, so it will be equal to 0. I already have the value for I2, so put the value for I2. So value for I2 which I got is 1.66, so this will be upon dt equal to, so if you shift that side, so I2 value which you got is 1.66, right, divide by, it should be 10 raised to minus 6 into, if you shift 20 over here, it will multiply into 20, that's the value which you get, it's 8.3 into, so it will calculate 1, 2, 3, 4, so it will be 8.3 into 10 raised to 4, this is nothing but ampere per second. So that's the way you do it. So this is what you got di upon dt after solving this sum. So this is what was expected from the sum. So I hope you have got few points for it, and I hope you keep practicing for it, because transient analysis needs lots of practice. Thank you so much. Signing out, guys.